Good morning, students. In previous video we have discussed about the center of mass and all, and I gave you some homework also. I believe that you all did your homework well, and today we are going to start a new topic, torque. You can use torque or torque, anyway you can pronounce torque or torque. And a symbol, this is the symbol we are using for torque. You see, like this you have to put the symbol. The symbol name is tau. Symbol name is what? Tau. We are using this symbol. It is not T. Okay. So what is this torque? You know, in our daily life we are experiencing, we have several experience about this torque. One simple example if I am telling is, you are just entering your house. When you enter the house, you are opening your door. That means you are applying the force on the door. You can see that the door moves in circular motion, isn't it? Or the door moves straight? Is it linear motion? No. Door moves in when you apply the force on the door. Suppose you are pushing the door. When you push, you can see the door moves in a circular motion like this. So you are applying a force, it produces what? Circular motion, rotational motion. So that is what we are saying, torque. The force is used. The ability of the force to produce rotational motion. That is what we are saying, torque. Simple definition. Torque means what? Torque means what? The ability of a force to produce rotational motion is called what? Torque. Another example you can see is, suppose you are tightening some nuts. Some nuts you can see sometimes in our house and all we used to do. We are taking the shifter or plier or wrench to what? Tightening the nuts. When we tighten these nuts, we are, you see, suppose this is a nut. You are holding the spanner or the wrench or the plier like this, then we are applying the force like this. You see, nut, this is a spanner, you are applying force like this. So, at a point, about a point, this is a position vector R, you can tell. This is a force you are applying in this direction. Simple. From our daily life, you see, we are using tightening this nut, holding the spanner. This is a position vector. You are applying the force this direction. So you will get rotational motion. This is what we are saying, torque, or you can use another name, moment of force. Moment of force. So from this example, you can write the formula. You see, torque is equal to R cross F. Vector. Torque is equal to R cross F. And scientifically you can define this. There is a definition in textbook, page number 217. It is defined as the moment of external applied force at a point. You see, I told you this is a nut To tightening this nut, I am using a spanner and applying a force. So that is what a moment of force we are saying. What a torque is defined as the moment of applied force about any point or axis. This point, this is a point. About this point, I am applying the force. So torque is equal to R cross F. It is a vector product. It is a vector product, and its unit is Newton meter. Unit is what? Newton meter. You can use N, M. Capital N, small letter M. Newton meter. And its magnitude is, you can write the torque is equal to RF sin theta. This is what with the direction, only magnitude you can write the torque is equal to RF sin theta. This is the formula and the unit vector. This is the formula RF sin theta. Now, to find out this torque direction, there is a small method. So assume that there is a rule, right hand rule. You can hold your right hand like this. This palm, this is palm. This palm face or the palm shows the direction of force. Direction of force. And this thumb shows the direction of torque. This is what a rule. Understand? This palm shows what? Direction of force. When you curl this finger, this thumb will come like this. So this thumb shows direction of torque. Now how to apply? You see, this is, assume that this is a plane, a paper. Above this paper, you are keeping your hand like this, okay, like this. Suppose one object is there, like this, okay. One object is fixed at a point. You are applying the force. So when you are applying this force, assume that there is a paper and you are keeping your hand like this. Your thumb shows out of the paper. Your thumb shows out of the paper, and you are applying the rule like this. Means you can use this formula. Torque is equal to RF sin theta. So you can write perpendicular. So you can write RF perpendicular. Suppose you are using this rule in this direction into the paper. First case is you are applying this rule by keeping the torque, the direction of torque. This is the direction of torque, and the direction of torque is out of the paper. So the direction of the force must anti-clockwise. Anti-clockwise. Example, one object is like this. One object is like this. If this is the direction of the torque, then what? You see, this will rotate. Any object, if you are applying the force, that object will rotate anti-clockwise direction. Torque out of the paper, then that object rotate anti-clockwise direction. You can use this R sin theta perpendicular, which is, you can write what? R F perpendicular. Now this symbol is perpendicular symbol, so you can put R cross F perpendicular. Now suppose you are applying this torque into the paper, the direction of torque is into the paper, then you see the direction of force clockwise. This is clockwise, this is anti-clockwise. So the direction of torque out of the paper, then what? The direction of the force is anti-clockwise direction. If the direction of the torque is into the paper, then what? Direction of the force is in clockwise direction. This is how you can find out the direction of torque. Now you can use this formula. The same formula you can use R perpendicular R sin theta F. So R perpendicular cross F you can use. So here in page number 218 these formulas are given. Based on this rule, there are some cases when the torque will be maximum. When the torque will be maximum. This is our formula. First case is torque is equal to RF sin theta. This is our basic formula. The first case is, you say theta equal to 90 degree. Position vector, applied force. These two. For example, this is the object. You are applying the force 90 degree to this. You are applying the force 90 degree to this. So, what are? That is what? Theta equal to 90 degree. When theta equal to 90 degree, sin theta is equal to what? Sin 90 is equal to 1. So, torque is equal to RF into 1. So, torque will get RF. Listen here. Torque formula is RF sin theta. First case, theta is what? 90 degree. Like this. Applied force. And the position vector. Theta is what? Angle forming is 90 degree means torque will be maximum. Maximum torque. Maximum torque. Maximum torque. That is what. So, sin theta is 1. Sin theta is what? 90 degree. And theta is 90 degree. Sin 90 is what? 1. So, here substitute. You will get RF. Now the second case is theta equal to 0. Theta 0 means what? The force which we applied is in the same direction. Suppose this is what? This is the object and you are applying the force like this straight. So during this time force and both are in the same direction, then what will happen? What will happen? This force and the position vector in the same direction, then theta equal to 0. No angle between them. Both are in same direction. Now sin 0 equal to 0. So torque is equal to RF into 0. So torque is equal to 0. No torque. No torque. The object will not rotate. Now the third case is theta equal to 180 degree. This is the position vector. This is applied force. 180 degree. Now also what? No torque, because sin 180 is what? 0. So apply here, torque is equal to RF into 0. Again torque is equal to what? 0. No torque. And the last case is this F is over R. F is over R. Now also torque is equal to what? 0. Position vector along with that F. So no torque. So torque is maximum when this position vector and this one should be in 90 degree. This is what the best example. You can turn the nut. You are holding this spanner like this and you are applying the force 90 degree to the spanner. That's what it is easy to turn that nut. This is the application of torque. And old people, you know that check means the coconut mill where the coconut oil is producing. There they use what a long stick. At the end of the stick they will tie, either old people will tie the cow. Now machines are there, motors are there to rotate. It is one best example. You can see in page number 223. 223. While seeing this picture, you will understand. It is also the application of torque. So this is what about torque. You can use this formula, torque is equal to R cross F, and it is then what you can remember the rule what I told. Palm shows the direction of force. When you curl these fingers, this thumb point what the direction of torque, and I told how to apply. If it is out of the paper, then the what direction of then the object rotate anti-clockwise. If it is into the paper, object moves what clockwise. So you can use this formula. Then there are 4 cases. In which case torque will be maximum 90 degree. If the angle is 90 degree, torque will be maximum. Remaining all case what theta is 0. Now this is what introduction about the torque, and you can see in page number 217, 17, 18, 19. 4 cases are there. On table 5.1 is there. So until that you can go through that. Based on this example 5.8, it is very important problem. You have to practice. Very important problem. Example 5.8 also. Then next topic is it is given talk about an axis. Here on some examples only given. One example is Tamil Nadu old traditional game which is called silly code. In Malayalam it is said some vertically, not Malayalam, in our local area and all we use that word silly code, silly. In that game we know that you can see in page number 221, the picture on 2 girls are playing that game. In that game, where this torque need? You see, normally a person will stand. When we are standing like this, there will be downward force which is acting what? A gravitational force. To balance this gravitational force, there is an upward force called normal force. So gravitational force and the normal force which is acting in the same line. So you are not falling. No torque is forming there. But when you play this game, you know you are playing with one leg. Sometimes your body will lean like this while you are playing this game. Why it is happening means, this is the reason. You see, the gravitational force which is acting downward and the normal force which is acting upward not in the same line. Now what is happening? A torque is forming, so your body start to rotate. That's what this concept and they are nothing important. Then the next topic, an important 3-mark question, relation between torque and angular acceleration. Okay. Relation between torque and the angular acceleration. This relation is given in the page number 224. Assume that one bulk object like this, one bulk object which is fixed on an axis. Now one point mass is kept at this place from this position, R position vector. This is an axis. Now due to this point mass, this object start to rotate. Here there is a tangential force F is acting. So due to this tangential force F acting on the point of mass, this object rotates. So it produces torque. So you can write the equation torque is equal to R F sin theta. Torque is equal to R of sin theta. You see, tangential force which is acting 90 degree to this position vector. So sin theta is equal to what? 90 degree. Sin theta equal to 90 degree. Theta equal to 90 degree. So sin theta torque is equal to RF sin 90. What is sin 90 value? Sin 90 is equal to 1. So torque is equal to RF into 1 is what? RF. So there is a torque. So there is a torque, maximum torque. Now you see, you know this formula, F is equal to what? Newton's formula, F is equal to ma. F is equal to ma. So instead of this ma, torque is equal to R into M into A. Instead of this F, we are applying ma. Now, acceleration. What is the formula? Angular acceleration. A is equal to R alpha. A is equal to R alpha. This is what acceleration, angular acceleration formula. So, torque is equal to R into M into, instead of A, what? R alpha. R into R. So, torque is equal to R square M alpha. Okay. Now this equation you can rearrange and write torque is equal to mr square alpha. Rearrange and wrote. Now this mr square, there is a concept behind this mr square. Mr square means moment of inertia. Is moment of inertia I. Mr square means moment of inertia I. The detailed we will study in this same unit of next topic. This mr square means I. Moment of inertia formula is I is equal to mr square. So torque is equal to what we can write down? I alpha. From here we can write this is a formula we are using. This is what the relation between torque and angular acceleration. And here we are using a bulk body, a rigid body. Rigid body means there will be so many point mass. So you can use this what torque is equal to, instead of mr square you can use sigma mi square into alpha. Okay. So instead of this you can use what? sigma m I r I square means what? I only we are using. The relation is what? Torque is equal to I alpha. So again, assume that you can see this page number 224. One diagram is there. The diagram also you have to draw. Consider a rigid body rotating about an axis, and in that you see you are keeping a point mass. A point mass m is keeping on that, and there is a tangential force which is acting on this point mass. This tangential force acting on the point mass is the reason why this object rotate about this fixed axis. Now torque formula R of sin theta. Here what are? Here the force and the position vector which is at 90 degree to each other. So theta value is 90 degree. Sin theta is what? Sin 90 is 1. So next what are? RF into 1 RF. Then you have to use force Newton's formula, F is equal to ma. Now instead of this F, ma you are using R into ma, and the A formula is what? Angular acceleration R alpha. R alpha we are using, so R into R square m alpha. Then what? mr square is moment of inertia I alpha. So here we are using a bulk body, rigid body. So what? There will be many point mass, so you can use mr square instead of sigma mi ri square. That is also same as moment of inertia. And this is one important 3-mark question. You have to practice. This is also this is one of the homework, and already I gave that example 5.8 also homework. Practice this. These two are important thing in this part. Thank you all.